Okay, let's now finish up Chapter 1. Very short chapter, only 3 sections. Again, it's just more vocabulary. This section focuses on types of studies, types of experiments where you can gather data. So observational studies are things that you observe, but you do not actually try to institute any change. So, you can think of it as it's like you're watching, whereas an experiment is where you have made some change. For example, you have given them some medicine, and then you're going to see what the results are going to be. And so you want to measure the observed results. One of the most important aspects, really, especially when you get into interpreting statistical data, is lurking and confounding variables. And the key here is that you may think you're studying one thing, but in truth, the results that you get may be due to something else. And if you're not aware that something else may affect your data, that could really skew your results. And so you think you've got a very valid interpretation, but then it turns out something that you weren't even aware of or weren't really consciously thinking about got in the way. Replication is the idea behind that if you were to do your experiment or your study several times, do you get the same results each time? Blinding has to do with whether or not, basically, it starts off with, do you have a control group? So do you have a group in which nothing is being done to? And then you have the group that's being treated. And the idea behind blinding is the people in the two different groups don't actually know whether they're getting a treatment or just being observed. They may be given a placebo, which is something that doesn't actually do anything, but it counteracts the idea of a sort of positive thinking. You think you're getting medicine, and therefore you start to feel better. And sometimes that can actually happen, that a person does get better just because of their positive attitude. And you really want to distinguish between that relatively rare occurrence and whether the medicine is actually working. Double-blind is where the people who are performing the study or experiment also don't know who is getting the treatment and who is getting the placebo. And then the rest of the chapter pretty much just talks about sampling techniques. First of all, we have random samples, where every member of a population has an equal chance of being selected. It is a simple random sample when not only every member, but every group of the same size has an equal chance of being selected. There are other techniques that you can use. You can use what's called a stratified sample, in which it's important that you have every different segment in the population represented. So, for instance, if you were doing something in which you wanted to make sure there were poor people and middle class people and rich people of various degrees, you would want to make sure that every single one of those categories had some representation in them. There is cluster sampling, in which basically you divide the groups or the area under study in a systematic way, and then you randomly select portions of that, and those are called clusters. So, for instance, you could divide, a state by its zip codes, and then randomly select certain zip codes, and then everyone who was in a particular zip code that was selected would be part of the sample that you had selected. And then finally, there are systematic samplings in which every member of the population under study is assigned a number, and then you do some kind of regular intervals. So, for instance, let's say that you're choosing every 10th person who comes into the store. That would be a systematic way of sampling. So that's pretty much it for this section. Let's go over a few examples now. So to start off, you want to conduct a study to determine whether fruit consumption leads to reduced weight. Why would an experiment be better than an observational study? So if we're doing an experiment, we might be looking at how much fruit they're actually consuming, and then relating that to how much weight was lost. On the other hand, if it was an observational study, we might just be observing how much fruit they actually consumed, and then connected that to reduced weight. So slightly different things. Why would an experiment be better than an observational study? So in an observational study, you can observe how much fruit people eat, but you could not tell if a person's reduced weight was due to a lurking or confounding variable like how much they exercise. So if you were doing an experiment, not only would you perhaps want to look at how much fruit they were eating, but you would want to set up the conditions so that you were making sure about all the other factors that might go into weight loss as well. So you might somehow normalize or limit how much exercising they're doing, so that all the people in the sample, that particular variable would not come into play. You might want to also look at something like, what else was in their diet besides just the fruit. In other words, just the one thing that you were really focused on. In an experiment, you would have the ability to perhaps control more of those potential confounding events, whereas in just an observation, you would just see what they did and not be able to separate that from, or at least isolate what in fact was the key to whether or not they lost weight. All right, so in a clinical trial of cholesterol drug Lipitor, 188 subjects were given 20 milligram doses of the drug, and 3.7% of them experienced nausea. Is this trial experimental or observational, and why? This would be experimental because they've been given a drug, they're taking the drug, and then you are recording how many of them had a particular side effect. So if it had been observational, then you would not have given them the Lipitor. You would have just been observing what's going on. You tried to make a change. That's what made it experimental. All right. Studies conducted during the lockdown, so that we're talking about basically last spring, found that fewer cases of the virus involved children, and therefore children were less likely to acquire it. You may have, in fact, heard this claim being made now that people are thinking about going back to school. So, the question is, what variable might have been overlooked? Initially when these comments were being made, it's like, oh, okay. And then I saw this one article, and I was like, wow, that was something I had never considered before. The variable that had been overlooked was the number of contacts. When the lockdown, including schools, was put in place, it also meant that basically children stayed home. And so they had fewer contacts than adults did in general who were still going out. Maybe, whether they were essential workers going out to their jobs, or they were, going to the grocery store, the bank, gas station, whatever. In general, adults had more contacts per day than the children did. And so, what some started to realize is it wasn't just in general, whether it was social distancing or wearing masks or whatever, it's basically how many contacts are you having with others. And the more contacts you have, the more likely it is for you to get the virus. And so, that was something that I came across in July, but no one was really talking about in March and April. Okay. A poll is done by the Great Survey Company. It polls exactly 750 adult men and 750 adult women, randomly selected from adults in the United States. Is this a simple random sample? It is not a simple random sample. I know it says randomly selected, but the key here is not every sample of 1,500 adults would have an equal number of men and women being selected. Turns out, of course, there are actually more women in the United States than men overall, and so by making the two groups equal, you also run the risk that you biased it slightly because it's not matching the actual population. But to be a simple random sample, every group of 1,500 adults has to have an equal chance of being selected. So you would potentially have all women or all men, or maybe, 1/3 women and 2/3 men. All those different groups would have to have an equal chance of being selected for it to be a simple random sample. All right, I think our last question. Zip codes are randomly selected in a study. So this would be an example of cluster sampling. Zip codes are randomly selected. Why might the study's results not represent the entire population? Again, the whole point of doing random samples is so that you can do a subset of the whole population, but end up with results that reflect what would be true for the whole population, so that you don't actually have to poll the entire population. So what if we chose zip codes? Why might that be a problem? The fact of the matter is, each zip code is not really representative of the entire population. You have some that are made up of very wealthy citizens or very highly educated ones, while others do not. Sort of the poor side of town versus the well-to-do side of town. If you had a zip code that had a college or university in it versus a zip code that did not, you might get very different results and therefore not necessarily represent the entire population. It's convenient to be able to select people that way, but again, the best kind of studies are ones in which your answers will reflect what would have been true for the entire population. So that ends section 3. Very short chapter. In the next chapter, we'll start getting into how to display data. But for now, this will finish chapter 1.